Hello. Today you will see that we have a slightly different setup for our Arduino Mega project. This actually is a voice-controlled TV remote. What I've done is I've taken two other projects, the TV remote and the VR, the EasyVR 3 Shield, which is on here, and combined them to get a voice-controlled TV remote that doesn't require any laptop. And in fact, I will be able to program this remote onto this SD card. So let me show you what I have here. Here we have a small TV. We have the Shield, the EasyVR 3 Shield here, mounted on top of a Mega, an Arduino Mega. I also have an SD card here with a 1 gigabyte chip in it. We have a microphone, a small 8-ohm speaker, an I2C LCD display, and then we have an IR receiver over here. And we're using the power from an Apple recharging plug, USB plug to charge the Arduino. So we're completely self-contained here. So you could actually put this into a little package and put it on your coffee table and use it to control your TV. So that being said, basically there's two modes. You can do play mode or learn mode. Play mode, you just say the command into the speaker. It'll prompt you on the, say the command into the microphone, it'll prompt you on the speaker. If the command is bad, the red LED will go on. If the command is good, you'll get the green light, and then it will process the code and send the code through the transmission or transmitter IR to the TV. If you're in learn mode, you'll receive the codes from the remote into the IR receive LED, and I have it in a little container here, a little cover, so that you don't get spurious errors in reading the remote. It'll then get processed, and once you get 2 reads in a row, it will then write it to the SD card and save it at an offset, so that when you go to play it, it reads it at that offset and then plays the correct code. So that being said, let's go ahead and I'm going to dim down the lights a little bit and then turn it on, and you will see how it works. So there you go. You can see it's trying to pick up some of my commands. The red light is going on. Let me give you a little bit more light here, just so we can kind of see a little bit. It's still picking up my voice. So, and it continually prompts us. So let's go ahead and say a command. You don't want to speak when the LED is on because it's processing an error code and it won't pick up your command. So let's wait until the command is off. So you thought I said learn mode. So let's reset this. Play mode. Play mode.
Play mode. Please say a command. For example, power.
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 So it'll process that command, and now it's continuing to ask us for more commands until we say the one command that stops the play mode. And it's still picking up my voice. You can set a trigger so that it doesn't keep doing that, but then you got to keep saying the trigger over and over, and I didn't want to do that. Mute. Mute.
Mute.
You do have to get close enough for it to hear you. Volume up. Volume up.
Volume up.
Source.
Source.
Arrow up.
Arrow up.
Arrow up. Arrow up. Now in that case, it took longer to process and the TV timed out on the display. Power.
Power.
Done.
Done.
And that's the command that stops the play mode.
Play mode on learn mode.
So let's try learn mode, where we take the remote and we aim it
Play mode on learn mode.
into the receiving IR. Learn mode.
Please play mode on learn mode.
Learn mode. Learn mode.
Learn mode. You will have 2 tries. Please press power. Read 1. Read 2. You read.
Now that turned the TV on, obviously, because the TV is still plugged in.
Press number 1.
So we'll go through all the commands on the remote. We'll do number 1.
Read 2.
And this time I'll hit power, so they should mismatch.
Read error. Try again. Read 1.
So it's going to continually go through all the buttons until you get 2 entries that are identical in a row, and then it will write it to the SD card. And you have to go through all these buttons, so it takes a little bit of time. So let's get a little bit more light in here so that we can you can kind of see how this all works. So with that being said, that's basically how this works. Then it just goes back to, once you got all the buttons programmed, it goes back to the main menu, play mode or remote, and you're basically done. Some things I want to mention with this. There are some jumpers back here. When you go to program the EasyVR Shield, I wrote the company, and they said that you can basically move the jumper from the 2 positions in the back with the power on. I've had a couple problems with that, so I would suggest unplugging it if you can, before you move that jumper. Another thing is, in order for the 2 boards to communicate, you have to load the bootstrap code that is in the example when you load the libraries for the EasyVR Shield. There's one called Bootstrap Sketch or something, and it's the very first one. There's only 2. One's a test and one's the Bootstrap. Otherwise, you can't use the Commander program that comes with it to add the sound waves or the wave files or the dedicated sounds that commands that you give. So that's something that's in the manual, but it's easier if I just tell you now. Also, when you display on the LCD, if you decide to use an LCD, if you display the characters on the display, it's best to put the command to display the LCD before the voice command, because if you do the voice will be done before the LCD gets fully displayed. It takes a little bit of time for that. If you are going to program in your sketch to use built-in, I would suggest using the built-in speaker independent commands. There's like 3 groups towards the bottom of the software commander program. One of them is numbers, one of them is action, another one's something else. And that way, if you accidentally delete the speaker dependent codes, you can always use the built-in speaker independent commands, because they're never deleted. They're always there. And once you get this kit, that'll make more sense. Also, I was thinking, if you want to make it so that it's software to jump between these 2 pins, that's initially why I contacted the company, because I want to be able to move this jumper while the power is on. I was thinking of using a relay or some sort of IC switch software-wise in order to program the board and upload maybe wave files, custom wave files or something like that. So instead of having a physical switch or having to physically move this, you could do it with either a relay, an electromechanical magnetic little relay, or an IC chip. Let's see, I think that's just about it. One last thing I do want to emphasize emphasize is you should have some sort of LED that shows when it's processing an error message, let's say, or when it gets a good read, and then shuts off so that you know you can talk. Because often what happens is if you don't have some sort of indication, you'll start to say a command and you only get half the command in and you'll keep getting these errors. And so if you have some sort of visual cue, either the light goes on or the light goes off for you to speak, you'll get a lot better results, and your timing to give that command will be better. So it is a little bit tricky to get the voice. There's a distance and a sensitivity and a few other things that you can set in your code so that the mic picks up more of your commands. However, that also picks up background noise, and you could tell that this red LED was going on when I was just talking. So that's actually something to keep in mind. Other than that, I think that's just about it. I'm going to now show the code up close and go through the code, and we can step through it step by step, because there's a couple key commands in the code that actually helped me with a previous project I did with the EasyVR 3 Shield in a prior video, and the remote in a prior YouTube video. So you can look at those too if you want to get kind of more specifics on each of the functionalities. I'm trying to keep this this video a little bit shorter and a little bit quicker because I have those other two that kind of go more in depth. So I think we'll go over to the code. Okay, so here we have the code sketch for the EasyVR 3 TV remote that I showed you. There are a lot of libraries that are required for this to work, so it's good to keep them in separate areas, and so you can deal with them one at a time if there's an issue. The first one I load is the EasyVR 3 voice recognition shield. This code is generated automatically by the EasyVR Commander program generate code option. It is all necessary in order to establish bridging for the EasyVR 3 Shield to communicate with the Arduino. So I've tried to remove some of this stuff. No, not a good idea. So leave it all in. One line I did add was this pragma once, and what it does is it stops multiple opening of the same .h files. So that will reduce the number of compiler confusion when you compile your sketch, so that you don't get multiple .h files opening, because there are a lot of libraries, like I said. So this is all generated for you, but I went through and edited it a little bit. I'm only using two groups. Group 0 and Group 1. Group 0 is basically the trigger group. I haven't used it yet. The word robot comes with the command set. I added remote just in case in the future I want to add that trigger. I can. A trigger basically has the EasyVR 3 Shield in a kind of a suspend mode. It doesn't do anything until it hears this one unique word, and then it wakes up and starts processing whatever you want it to do, these other commands or whatever. Until then, it doesn't do anything. And you may need that if you actually have a TV in the background playing and you don't want to capture all that extra, have it start going off and doing wild things, programming it and that sort of thing. But for right now, I don't actually program the trigger command. But I do use all the Group 1 commands that I put in. These are all the remotes, buttons that I program. You can program more or less, but these are the ones that I do. And I assign them a value. Power is equal to 0. Number 1 is equal to 1. Mute is equal to 13. I added 2 extra ones down here for learn and play mode, and then the last one for the done command, which is part of the play mode command. Basically, you can go into play mode. You keep doing play mode until you say done, and then it kicks out, but I'll explain that later. You can reference each one of these commands either by G1 underscore power, or you can reference it by the number 0, and I'll show you that down below too. Here's some other variables. Here's the IR LED libraries that I include. Here's for the receive pin, which has to be on 11. Here's the send pin, which has to be on 9. And then some other variables that I use for calculating stuff. So the variable used to convert characters of the hex code command stored on the SD card, then I convert them from a character to a decimal. Next, I raise it to a power to the, for each character. Lastly, I store a running total in the total decode number, and finally print it as a hex number matching the command stored on the SD card. Each command is stored on the card at a seek offset of 10. So that's what I do here. I get a character from the card, I convert it to an integer. Here's the power that I need to calculate that number. I think is just an integer for a for loop. Here's the decoded number that I from the character that I got, and then here's the total running total number, adding up all these decoded numbers, and here's the file offset for play mode. I have another file offset down here for learn mode, so I could have used the same one, I just didn't. That brings us to the library for the SD cards, and this is all predetermined. Here's the library here. I set the chip select to 53 because I have a Mega. The Uno is going to be different. Here's the file that I'm going to open on the SD card, and like I said, here's one of the offsets. Here's the wire library that's all pre-done for you, but there are a lot of libraries, and often you can get, have to open another wire library, so that pragma once definitely helps. This is all part of the LCD crystal, the I2C that I set up. This is the address of my LCD screen. This sets up the communication between the piggyback board or the backpack board and the LCD display. I try to use the LCD when possible. I want to make it standalone without a PC, so I need a little bit of wordage that I can read. This doesn't need to be there anymore because this was for debugging. I would enter the A through X instead of saying power or mute, so that actually can be removed. Mode option is it play mode or learn mode? Here I set the LED pins. The green is 31 pin 31, red is 33. I set them to false, and then I say play mode done, also false. And these are really the only variables I kind of really use other than the file offset. That brings us into the setup. We decide which bridge mode the EasyVR3 is going to use and initialize it. Start the IR receiver. Next, initialize the SD card and verify its functions. Lastly, set up the microphone sensitivity and distance for the user. There's a lot of initialization that goes on in the setup. Here we set up the EasyVR3. This is all done for you, and you've got to use it all. Do not remove any of it, because after a while it'll stop working, and then you got to put it in anyway. So while this is an error message, if it doesn't detect the EasyVR3, it tells you, and you got to do something about that. It could be that you have a jumper in the up position on the shield and not the software position. I've done that a couple times. It's like, ah, dang. So the serial print here, it was detected. I set a timeout to 0. 0 is infinite. That means it's just going to continue to wait and wait and wait for me to say something. Default is 5 seconds. It goes up to 31 seconds, I believe. So I set the language to English. Here's the trigger command that I commented it out. I may use a trigger in the future, not sure. We'll see. And then I play a bell saying, hey, we're ready to go. You initialize the serial 96 for the serial monitor. I use that for a while. I don't even use it now. I could take that out, I suppose. I set the pin 13 to output. That's part of the IR receive function. I set the LED pins as output, and then the IR send pin, the TX, as output. I do a digital write IR send pin to high. I think you have to do that. That was somewhere in the internet. I read that. Here's the IR receive. That enables the IR receive LED. You have to do this over and over, actually, and I'll be more specific when we get down to the code. But the IR receive LED did not work for a while after I did an IR send, and I couldn't figure it out. So you have to reinitialize it using this down in the function. Here's the LCD begin, set the screen size, backlighting, and then we clear it, get ready to display something. We set the CS pin as output. That's required by the SD library. Where we say we're initializing it. If everything's good, we flash. We go ahead and continue through the LED red, and we flash it. If there's an error, we say there's an error. There's SD card failure right here. That happens to me all the time because sometimes I take the card out to change some of the variables on the card, and I forget to put it back in, or I forget to plug the power into the SD card because you have to turn the power off, actually take off the red lead, so there's no power. When you remove that little SD card, you can zap your SD card. Then once I get everything straightened out, and it says initialization is complete, and then I set the mode for the mic. Here's the mic distance is 3, which is furthest away. I set the strictness, so it's very simple, and set the knob for confidence threshold, which is also very simple. It's at the lowest level. That way it takes almost anything from anywhere. You can tighten these up if you want, but I don't do that. In between the setup and the loop, which I find is interesting, this really seems to be the best place to put this code, is a long unsigned int. Maybe it has to be there, I don't know, but I tried to move it and couldn't. It didn't work. Anyway, I have 3 of them. They're all basically the same thing. I read an IR code, I store it in old, I read another IR code, I store it in new, and then I wind up comparing these two. And I explain that down in the function. But you have to do an IR code read twice in order to store it to the SD card. Here is where the loop begins. The loop cycles through requesting for play mode and learn mode. The 2 main functions are called, and they use a case statement to process the 2 commands, play mode, learn mode. The play mode has all of the keys from the TV remote isolated in one case statement, which is huge. A verbal speech request and an acknowledgement is made, then a call to send code is made to calculate the variable and transmit it to the TV. Each code is stored at the file offset stored in the file offset variable on the SD card. The learn mode function reads each key pressed twice to get a match. That's what I was telling you about above. Then writes the new code to the SD card. This process is repeated for all the keys on the TV remote. So what does that mean? Here's the loop. We clear it. We say play mode, learn mode. We give it some time to process. We play a sound saying, please say play mode or learn mode. Then we get index. And index I use over and over. Let me show you what that is. Get index. It's just a numeric number that right here. Here's play mode. Oops. Let's try that again. Fine. Here's the get index right here function. Reads the current group, which is in our case that I'm using is group 1 command, and return the index IDX value. So I set IDX some weird variable because I don't want it to be pre-initialized with something that actually is valid. And then I say group is the first group, group 1. And I do this do loop right here. And basically it sits and waits for a recognized command. This will poll it, and it'll sit here and wait for it to hear something. And as soon as it hears something, it sets that word that you said. It takes the index and stores it in this command. And one way to think of this command, or these groups of commands, is similar to, you could basically say that it's similar to if serial available, do something, and it'd be similar to this. Read input. It would be similar to these commands. I mean, you're familiar with these commands where you read an input and then you wait for the serial to be available for that input, and then you would have for instance, like this, x, this isn't quite right, but I'm doing it on the fly, x equals read input, serial read input. Let's say it's something like that, and then if serial. So basically, this waits until it gets this code. So it would come down here and stop, and you would put, you'd say print type in input, type in your number. So this command, these two commands, which you should be familiar with, are basically what these equate to. So I hope that kind of clarifies it. Where here you're reading the variable first, then you're waiting. Here you're waiting, and then you're getting your input. It's just kind of a different way of doing it. So I thought that might clarify things. So what it does is, if the index is a -1, then we set the red LED to true. We flash the LED saying that there's an error. And this while loop continues until IDX is not a -1, because the error returned from this read, all of this. If you don't give a valid command, it'll set IDX to -1, and that's an error. And so none of that will work. None of that get index. You have to get an index that's valid. It has to be a valid number for testing. So let's go back up. So once you get something that's not a -1, we go back up to the top. Let's see. This might actually... Here we go. So we're back at the top, and we get something that's not a -1. We get something that's either a 24 for play mode, or a 25 for learn mode, or it's some other number. It could be anything. It could be 32, who knows. If it's not a 24, not a 25, we end out of the if, we end out of the else, we go back to the top of the loop, we say press 1 for, either please say play mode or say learn mode. And it keeps doing that until it gets a 24 or 25. So let's say the IDX comes back as 24. We clear everything, we do the play mode, and then we say it. And this is something I need to bring up, is I always do the display first, then I say the command. If you reverse them, it gets confusing because the screen is cleared out and it's saying something you don't know really what it's saying. So always do the display first, then do the sound. So we've got a good 24 index value. We set green to true, and we flash it green, and then we say, please say a command, and here's play mode, and that's where you start saying commands to get it to do stuff on the TV. So let's find the play mode routine. Here it is here. And so in play mode, we listen for a voice command and play the command through the transmit IR LED TX. Continue to listen for commands until the done command is set. So we set the play mode done value to false. And while not play mode done, we say a command, and then we get that index, and that index right here, like I said at the beginning of this description of my code, it can be a 0 or it can be the actual label. I could easily have just labeled this G1 underscore power in uppercase. It doesn't matter. 0 and 1 the same thing. So we go through this huge case statement for play mode, depending on what you say. If you say power, it's going to run this. If you say number 1, it's going to run this, and so on and so forth, because it's going to calculate this index. And the index you've stored at in your commands up here, right here. Here's 0, 1, 2. And these are all words that you have coded in your group 1 on the EasyVR 3 Shield. So let's go back down. Let's see, let's learn mode. So here's the loop. So we go to play mode. And play mode is right here. And so let's say you say power, or and it'll flash the green, it'll show it, it'll play the sound, and then the offset is 0. So it knows where the word power, or the hex code for power, is stored at 0. The hex code for number 1 is stored at file offset 10. So you get the idea, and it goes on and on, 20 and 20. So once we get the file offset, we go to send code. So let's find send code. Oh, it's going to go through all of these. So you can see there's a lot of send codes, so maybe I should go down here to source. This is the last one. So here's send code. And send code is reads the remote hex code from the SD card, then calculates the numeric integer, then sends the value out to the IR LED. And so it decodes, decode number is 0. Character to int is a character 0, and the total decode number is a 0. And so we go to My File, SD, we open this text command file, and we open it for read. We delay a little bit of time, and then we start at the file offset. We calculate the file offset number. And for I equals 1, 2, less than 9, which is 8, we get My File, we read the first character, give it some time. We set the power to 8 minus 1, which is now 7. And if the character is between 0 and 9, or A through F, we calculate the power accordingly. So let me give you an example. If we have a value E0B4 1 2 3 4 is the code for, let's say, power, or not power, let's say the code for volume up or something. We take this first character, which is an E, it falls in here. E minus 55 will be 14, and we say the character int is now 14, and our power is 8 minus 1, which is 7. So we go down to 7, so we say decode number equals 14 times power of 16 to the 7th exponent. And so that's a huge number, and that's now stored in decode number. And total number is 0 the first time through, so now total number, decode number, equals the first decode number. And we come through and we pick off the second character, let's say it's 0, and power is now 8 minus 2, which is 6, so we go down to 6. And decode number equals character to int, which character to int is, since it's a 0, it's up here, and we say 0 minus 48 is 0, and the power up here is still 6, so we go down to 6. 0 times anything raised to the 6th power is 0. We add total decode plus the new decoded number, which is 0, and we continue doing that for each and every of the characters in the hex digit. So that gives us our total decode number. We close that. We fall out of this N4, this for loop. We close the file. We delay. We then send the NEC code to the IR, and it broadcasts the whatever code this hex code is. And you could have multiple sends here. I know that my remote is an NEC, but it could be a Sony, it could be an RCA, and you could just have a bunch of them listed here, and maybe a flag that says, hey, if it comes true, stop processing them and be done. So that is all that the send code does. And back up here, that's the end of the play mode. Let me get back up to the top, because you're playing each one of these commands. So here's play mode, and that's the end of play mode, and it'll keep doing that until I actually should show you something in play mode here. We go back to play mode, and it processes this and comes through here, and that's the send code. And once it's done, it breaks out. And each one of these case statements is exactly the same, and it keeps going through until you get it done, and it flashes green and it prints done, and then now play mode equals true, which allows it to end this while statement up here. While play mode not done. Well, play mode will be done, so it'll be done with the play mode completely, and then it will go back up to the top of the code up here. and end this if, and then come back up to here. So let's go ahead and go back up to the void loop right here, and we've already done the play mode. So now that we've got the IDX captured at 24 and we've done the play mode, the next will be the IDX equal to 25, which is learn mode. So let's start with learn mode, and we flash the green light and turn it on, saying that we got a good command. We display that on the screen, we delay a little bit, we play the sound, learn mode, and then we jump to learn mode. So right here we have learn mode, and in the learn mode we set up the LCD cursor. We say 2 tries, because you get 2 tries to learn a specific command. And it says here, let's just read what it says in the learn mode. The learn mode cycles through each of the buttons on the TV remote. The receiver IR LED RX will read each input twice and compare them. Once 2 consecutive inputs match the program will store the new confirmed input to the SD card at the proper offset and progress to the next input or button. Now, they don't have to be consecutive. They could just be equal, but I did them consecutive. That way I was pretty much guaranteed I got a good read. So after saying 2 tries, I set the old and the new IR codes to different, because I'm going to test for them being similar. I play a sound saying press the power button, and I display on the screen the power button. Here's the X offset to the file. We start out at 0 for the power button, and then we read the code from the remote. So let's find read code. Read code. Oh, it's going to go through all of these. So let's go down to the bottom of this huge case statement. It does the same code for each and every option. So here we have, let's say just the last one, source. We'll read the code here. The offset obviously is different, but here's read code. Control F, read code. Let's find the next read code. Here's read code. Read code from the remote, then compare until 2 consecutive inputs are equal. Here's that command I told you that you have to restart the IR receiver. Every time you do transmit, it somehow messes up, and so you have to do a restart. So every time you come in the IR, every time you come into the read code, you might as well restart the IR receiver. And then we come down to this do loop, and we play a sound saying read number 1, and here you wait for some sort of input to the IR LED. And once you get a code, a hex value, you store that IR code into the IR code old. And you give it a little bit of time to do that. And that could be actually less time, but it doesn't matter. And then you resume the IR reading, because you have another read to do. So here's read number 2. And we read the code and we store that in the new. So the difference between this and this is the old one, this is the new one. We resume, and then we compare, check to see if they're equal. If they're not equal, which could happen because you get static reads, erroneous reads from just light bouncing around near a window or other remotes. We say the red LED is set to true, so we flash a red. We play a sound that says read error. Here's the display of the read error. We give it a little bit of time to do that. And then we say try again, and you try reading again. And you keep reading until the IR code old and the IR code new from the 2 reads are actually equal. This says not equal, so it's going to continue to do it. But once it's equal, it falls out. You flash the green light. You play the sound saying good read. I actually ring a bell here because that to me kind of helps me a little bit. I wait 2 seconds, probably a little bit longer, don't need to. And that is basically the end of it. I wait 2 seconds, and that's the end of the read code. So let's go way back up here to our code here, our play mode, and I'm sorry, not play mode, but read mode. Where are we? Read mode. way up here. We go back to the read mode, or learn mode, and here we are looking at the source one still. We've done the read code, so we've got a good code in the IR code or the IR old code or the IR new code. They're all the same. You can use any variable. And now we go to write that. And under the write, we go write to file. And the write to file is right here. Write to file. Write the IR code to the SD card at the X offset. So we gave the offset of 230 when we called this routine. That's already preset. So we open the SD card and we open the file to write. We give it some time to do that. And we check to see if the commands file is there. We want to make sure. If it's not, we need to flag an error and flag the red as true. Make sure your commands file, your text file has 8 characters or less. 1, 2, 3, 4, 5, 6, 7, 8 characters or less, which it does. If there is no error, we seek to that position. Each command has its own position. We write that hex code, that IR code actually, and this could be IR new or IR old code, it doesn't matter. We write it as a hex value, and then we close that value, that file. We wait a little bit to give it some time to close. And then we're done with the write to file. That's the last portion of the learn mode. So let's go back up to learn mode. This is play mode. This is all play mode. We go back up. Sorry about this. These case statements are huge. Here's the end of learn mode. And here was the command that we just did. We did the source. We offset 230. We read the code. We wrote the code. And now we're done with the learn mode. And if we go back up to the loop that called this, here's the end of the loop. Here's the learn mode because we got an IDX25. We did all this. We played a sound. We did the learn mode. We're now done. Now we're done with the else statement. We're now done with the loop. We go back to the beginning of the loop and we start our play mode, learn mode all over again. And that's fundamentally the whole program. Pretty straightforward. There is one portion that I did not tell you about, which is this portion, the green light, red light flash LED, which is kind of cool. Let me show you that. Down here at the bottom, we have the flash LED. Turn that red or green LED on and off. Initially, at the top of the program, we initialized them as false. The red LED and the green LED flag. They're really flags. They're both false. And we turned off the red and green LEDs themselves by doing a digital write low. What you can also do here is use the flag as a high-low signal. Since we only send a true when we call this flash LED function, one of these will be true and the other will be false. And what you do is you do a digital write, red LED pin, and this will be true because we called it true up here. And when you do that, it will turn the red LED on using a true false option, which is kind of cool. Then you don't have to do if red LED equals true, then digital write, red LED pin high. You don't have to do that. You can just say true or false. I actually got this out of the Arduino reference, and it was kind of slick. So once we turn the pin on, regardless, and it doesn't matter, the red will go on or the green will go on depending on what value you send as true. We wait a second so we can see the light, and then we turn them both off. We say they're both false. We reset them here, and then we recall it here again with false, and that turns them off. And so it's kind of a slick thing. You don't have to do all these nested if statements and stuff. That gets kind of messy. So that being said, that's the end of the code, describing the code here. I have an overhead view of what the wiring actually looks like, and then I have a fritzing sketch that shows how to actually wire this up, and in the upper left-hand corner of the fritzing sketch, I will have the name of the, up here too, of the sketch name stored at CodeBender for you to download. I hope you like this. Please comment and subscribe. I will do more of these. The module, the EasyVR 3 module, is a very cool little module that can do quite a bit. And I've just started playing with it, but what I showed you here was what took me a long time to figure out how to actually use it in code and get it to do stuff and hear your voice and play custom waves and all that junk. I have another video that is the precursor to this that I suggest you take a look at too, because I kind of describe the basics. So again, subscribe and please like and share. Thank you. Here we have the fritzing sketch wiring diagram for this project. You will also notice that up in the left-hand corner is the file name for the sketch. Here we have the actual wiring of the project connecting all the modules together.